Hello everyone, this is the second part of the solution video to the problem extra characters in a string, where we'll see how we can utilize the tree data structure to make the solution faster. As you remember, when we were calculating our DP array, we had to match every word from the dictionary to the substring that ends at the position end in our original string. And those words had different lengths, and we matched them one by one. And here we want to use a tree to make that matching faster, to match all the characters at the same time, or the words in the dictionary at the same time, while going through the substring only once. Of course, a tree is a basic data structure that starts with an empty word and then has transitions for every possible letter from A to Z to other nodes. And those nodes represent a word starting from this root, and the letters in that word are the edge labels. So this node represents the word AB. Some nodes are marked, and that means that those nodes were present in the original dictionary. So at first we'll create the dictionary of our words, we'll have them reversed in the tree, because we're going to be matching them from the end. And now the basic idea is that if we want to, when we're at this position, look at what words we can create that end at this position, so what substrings ending here are correct words in the dictionary, then we can simply start from the last character, move backwards, and at the same time traverse the tree. And whenever at a tree we have a marked node, such as this one, that means that in our dictionary the reversed word was present, which matches exactly this substring. So we know that we can utilize this substring, use the word from a dictionary, and in that case we don't have any extra characters here, and we have to look at the DP for the previous position. So whenever we are at a position in our string and we want to match all the possible words in the dictionary backwards that end at that position, we just go through all the letters backwards, from the end minus first letter all the way down to 0 inclusive, and we try to descend the tree by that letter. If it's no longer possible to descend because the child doesn't exist of the current node, then we just break, because no more words from the dictionary can match here. Otherwise, it's possible that some words are matched, so we descend the tree in the given direction, and if that node is marked, then we can use it for our DP. So our DP is minimized with the DP at the position that we're currently at. And at the end, of course, we still return the DP for the whole string.